All right, I'm gonna share my screen. All right, y'all. So like I said, this is 2.4, and it deals with what we call the algebra of functions. And we'll be doing the 4 basic operations on these functions. We'll be adding, subtracting, multiply, and divide. So to get us started, I'm going to give you some terminology. So given 2 functions, f of x and g of x. So the first operation will be addition. So f plus g of x equals f of x plus g of x. And really, when you're adding functions, the only thing you can do when you're adding functions is combine like terms. And also with adding, you're not required to have to drop parentheses in order to add them, because the addition will not change the signs like subtraction will. So basically, the sum of 2 functions is take both them functions, add them together by combining like terms. F minus g of x will be f of x minus g of x. So subtraction is a little bit different. So when you're subtracting functions, the first thing you want to do is distribute the subtraction to get rid of parentheses. Once we get rid of parentheses, combine like terms. And that's why we was hitting y'all up with some of the support questions where you had to distribute that negative. Okay, so adding, I can drop parentheses, everything stays the same, combine with like terms. Subtraction, distribute the subtraction through the parentheses that follow, then add like terms. Next, we got f times g of x. So that'll be f of x times g of x. So this is where we'll use the distributive property or FOIL. Then add like terms. So we did a little practice on foiling the other day. So once we foil, then if needed, we added the like terms and then we were done. And finally, we have f divided by g of x. That'll be our f of x divided by g of x. Now remember, since I'm dividing, g of x cannot equal 0. All right, so those are going to be our 4 operations. So we'll be adding functions, subtracting, multiplying, and dividing. All right, and usually when I write my functions out, I start out by putting them in parentheses. And I'll show you all on this problem. So this problem I'm given f of x equals x squared plus 2. G of x is going to equal x plus 3. They want me to find f plus g of x. All right, so this is the addition. So I'm going to come down here. F plus g of x will equal my f function plus my g function. So f, we bring down our x squared plus 2. And g, I'll bring down my x plus 3. All right, so like I said, since I'm adding, I can drop parentheses without changing any signs. So I'll come down with my x squared plus my 2 plus my x plus my 3. All right, so now we need to simplify this by combining like terms. And the only like terms I have on here are my numbers, 2 and 3. Now, what I'm going to do is I'm going to put this in what we call descending order with my variables, starting with the highest exponent and working my way down. So my highest exponent is a 2, so I'm going to bring down my x squared. Then I'll bring down that x. Then I'll put my numbers. So now my like terms are 2 plus 3, which would give me 5. So my final answer on that would be x squared plus x plus 5. So y'all, any questions on that? All righty, so let's go to our next one. So this one, y'all, we're given f of x is going to equal x squared minus 4. G of x is going to equal x minus 2. They want us to find f times g of x. So it looks like they got a little multiplication going on this time. Now, y'all be careful. Sometimes they'll use a dot for multiplication. Sometimes they'll just put the letters right next to each other, like f of g, to imply multiplication. So f times g of x will equal my f function times my g function. So f is x squared minus 4. And then g would be x minus 2. All right, y'all. So to get rid of these parentheses, we're going to FOIL this. Since I got 2 things times 2 things, I'm just going to FOIL it. Now remember, I'm going to multiply these x's. So I'm going to act like the exponent on the second x is a 1. That way, when I multiply my x's, I'm just going to add those exponents. So I'm going to come in here, the x squared times x. 2 plus 1 gives me an x to the third. I'm going to take the x squared times negative 2. That'll give me a negative 2x squared. Then I'm going to take the negative 4 times x, and I'll get a negative 4x. And then finally, y'all, the negative 4 times negative 2 will give me a positive 8. All right, y'all, so can we go further on that one? All right, good job. So since I don't have any like terms, remember, Kara, I gotta have like terms to go further. So all I got is my x3s, my x squareds, my x's, and then my a. So since I don't have any more like terms, that will be our final answer. All right, so this was a sort of tricky one. I'm giving you f of x is going to equal x squared minus 3. G of x is going to equal x minus 1. They want us to find g times g of x. So we know we're multiplying, so our g times g of x, we know we're going to have two functions being multiplied. So y'all, here's the question. What's going in each of these parentheses? So let's start out. What's going in the first parentheses? All right, good job, x minus 1. But remember, this is g times g. So they threw y'all a curveball by even giving you the f, because we don't even need the f in this one. They want g times g. Good job. That'll be the x minus 1 times the x minus 1. Now, you also remember, both of my x's got a 1 on them. So x times x, 1 plus 1 gives me an x to the second. X times negative 1 is a negative x. Negative 1 times x is a negative x. And y'all, finally, that negative 1 times that negative 1 gives me a positive 1. Can I go further? All right, so it looks like y'all are definitely hitting yes on that one. All right, because I do have like terms in the middle. So bring down our x squared. Negative 1 and negative 1 give us a negative 2x plus our 1. So, although they give you these functions, pay attention to what they're putting down here when they want you to find, okay? All right, also, any questions yet? So y'all look like y'all are ready to roll on. All right, given f of x equals negative 18x plus 8. G of x is going to equal x squared plus 5. They want me to find f of 2 plus g of 2. All right, so here we go. F of 2 plus g of 2 is going to equal my f equation plus my g. But y'all remember, I'm not going to put negative 18 times x plus 8 in here, because now they're telling me to put in a 2, not an x. So when we write this, we got to put 2's in for the x's. So that would give you negative 18 times 2 plus 8. And then g of 2. So they want me to put a 2 in for that x also, which would give me a 2 squared plus 5. So y'all be careful when they throw something in here in place of those x's. That means I got to replace that number into it, okay? All right, so what we're going to do, we got to work inside each parenthesis first, order of operations. So in my first parentheses, I'm going to multiply first. So negative 18 and 2 would give you a negative 36 plus your 8. In the second parentheses, I'm going to do the exponent before I add. So 2 to the second power would give me a 4, and then bring down my 5. All right, so if you notice now, all we got to do is add inside each parenthesis, and that'll give me a single number. So since I'm getting a single number now, I can drop parentheses. So negative 36 and 8 would give you a negative 28. Plus over here, I got 4 plus 5, which gives me a 9. All right, I'm outside the parentheses. The only thing I got left to do is add these. So I got unlike signs. So a negative 28 and a positive 9 would give me what? A negative, what was that, 17, 28 minus 9. So that'd be what, a negative 17. No, that's a 19, right? All right. Negative 19. So I should have been watching my chat. You already had that up there. Good job. All right, also question on those when you're actually putting in numbers. Now remember, at this point right here, you could have punched it in your calculator just like it looks. Use your parentheses, come out of parentheses, put your next set of parentheses, hit enter. Calculator would have spit that out really quick, okay? All right, y'all. So this one, f of x is going to equal negative 11x plus 6. G of x is going to equal x squared plus 14. They want us to find f of negative 5 divided by g of negative 5. So y'all are now throwing a little division at us. So here we go. We're going to f of negative 5 divided by g of negative 5. Now, I always put my fractions in parentheses when I got more than one part on top and bottom. Especially if you're going to evaluate this using your calculator, you got to put parentheses around your numerator and denominator. So on top was the f of negative 5. So where that x is, I need to put a negative 5. So that's going to give us a negative 11 times negative 5 plus our 6. Same thing on the bottom. That was a g of negative 5. So that's going to equal negative 5 squared plus 14. And y'all, it's important when you got a negative number and you're raising it to an exponent, you got to put negative numbers in parentheses. All right, so order of operations on top, I got to multiply before I can add. So negative 11 times negative 5 is a positive 55 plus my 6. On bottom, negative 5 squared, I got to work that before I can add. So negative 5 squared is a positive 25 plus my 14. All right, y'all, so let's see what we got. 55 and 6 is what, 61. 25 and 14 is 39. So the question is, will that simplify? Oh, good job. Taylor said no. Claire said no. And if you want to check that, all you got to do is this: 61 divided by 39. That's going to give you a decimal. Hit the math button. It's going to turn this back into a fraction. And it gives me 61 over 39 back. So anytime it gives you back what you started with, it will not reduce. So final answer would be 61 over our 39, okay? But y'all, the main thing, if you did this by hand on the calculator, I mean, you would definitely need all those extra parentheses. All right, this one I'm giving f of x equals 3x minus 6. G of x equals 9x minus 2. They want me to find f minus g of an x. So sometimes they'll just give you a variable here. Sometimes they're going to throw a number in there, okay? All right, y'all, so here we go. F minus g of x is going to equal my f minus my g. Remember, f was 3x minus 6. G was 9x minus 2. So do y'all want to give me the next line? What y'all think is about to go down there? Okay, so we're saying distribute the negative. So let's see, we bring out the 3x minus 6. Distribute the negative, makes that a negative 9x. Good job. Oh, I think I got you, Michaela. Because guess what? You're about to distribute that negative to that negative 2. So remember, when you distribute a negative in there times a negative 2, that's actually going to make that a positive 2. Okay. Now, Kira, let me tell you, the reason you're not foiling this is because you got that subtraction right in the middle. Remember, when I foil, those parentheses will be right up against each other, okay? And y'all, guess what? I got 2 sets of like terms. My x's are like terms. So 3 and a negative 9 would give you a negative 6x. And then the negative 6 added to a positive 2 would give you a negative 4. All right, so the main thing y'all remember, when you distribute subtraction, it distributes to everything in those parentheses, okay? All right, let me see here. How about this? F of x is going to equal negative 2x plus 3. G of x is going to equal x squared minus 4. I'm going to find G minus f of x. All right, y'all, so I'm about to hit y'all up. G minus f of x. So I'm going to have subtraction. So here's a curveball. What would y'all put in the first parentheses? The G, there you go, because that's what the x squared minus 4. Y'all be careful. Sometimes they like to reverse that order on you. And then my F will go over here, which is what, a negative 2x plus 3. All right, so we know we're going to bring down that x squared minus 4. What's coming next? So let's see. Greg has what, a plus 2x. Because a negative and negative makes that a positive 2x. And then, good job, because you got the negative times the positive. Makes that a negative 3. In class. All righty. So now we've got that. We're going to add like terms, and the only like terms is that negative 4 and negative 3. So I'm just going to put them in order again. Bring down my x squared. Bring down my positive 2x. And then let's see, negative 4 and negative 3. Give me what, a negative 7. Oh, you got it already up there. X squared minus 2. Oh, okay, I see it. You got the plus there. Okay, good job. Okay, let's see what I want to hit next. Here's a good one. I have to throw some more curveballs at you. My f of x equals x squared minus 12. My g of x is going to equal 11 minus x. They want us to find f times g of an n. So y'all, here we go. F times g of n. So I'm multiplying, so I'm going to be multiplying my two functions. So do y'all want to take a guess at what I'm about to put into my first parentheses? So Taylor, you are what I would consider really, really, really close. But there's one thing I'm not going to do that you put up there. Because remember, what's sitting right there? So remember, instead of me putting in the x squared minus 12, since they're giving me n to replace my variable with, we would put the n in for the x, which would make this an n squared minus 12. And then over here, when I do my g, that's going to be 11 minus n, which is what they want me to put in. So it's basically the same thing. It's still a variable, but remember now they want me to put n as my variable, okay? All right, so now, since I'm multiplying, I will now FOIL this one out too, okay? All right, y'all, so here we go. N squared times 11 would be 11n squared. Now keep up with signs on these, because now I got a positive n squared times a negative n. That's going to give us a negative n to the third. So once more, treat that like a 1 and add exponents. Right now, distribute the negative 12. Negative 12 times 11. Ooh, what's 12 times 11? We know that'll be negative. Well, how about a negative 132? And y'all finally, that negative 12 times that negative n will make that a positive 12n. Now notice, there's no like terms. So unless MathLab tells you to put something in descending order, technically that's the correct answer. But what I'm going to do is put it in descending order just to get you practice at doing that. So the highest exponent was 3, so I'm going to bring the negative n to the third. Next is the n squared, so that'd be a positive 11n squared. Then I'd bring down my 12n, and then my minus 132. That way you can sort of get used to putting stuff in descending order for later, okay? So y'all, they're going to try to throw curveballs by throwing n's here and maybe other letters. Just plug that in for the x's and move on, okay? All right, let me see what I got here. All righty, so for this one, f of x is going to equal x squared minus 17. G of x is 13 minus x. They want us to find f divided by g of a negative 6. All right, so this one is division. So f divided by g of a negative 6 is going to equal my f divided by my g. Now remember, they're giving me a number for a replacement. So anywhere where I got these x's, I'm going to be putting in that negative 6. So y'all be careful with negatives. So I'm going to put in my negative 6, square it, minus 17. On bottom, I got 13 minus my negative 6. So first thing I would do on top was that exponent. And remember, any number to an even exponent will be positive, okay? So that negative 6 times negative 6 makes that a positive 36 minus 17. On the bottom, you'll see I got two negatives here. Those two negatives are going to make that a positive, so that this becomes a 13 plus 6. So remember, when you're subtracting a negative, make that positive. All right, you also on top, let's see, 36 minus 17 is that's like what, 19? On the bottom, you got 13 plus 6, which is 19. Oh my, Miss Davidson got that all the way down. 19 divided by 19 is definitely A1. Good job. All right, y'all, so questions on those. So next, we'll be doing these problems and playing with the domain again. So they're going to give us two functions. I'm going to have f of x equals x squared. I'm going to have g of x equals 4x minus 7. They want me to find the domain of the sum, difference, and product of F and G. So basically, this is 3 problems because I'm doing the sum, difference, and product. But all they want is the domain. They don't care about me simplifying these or anything. They just want the domain. Okay. So let me start out with adding. If I was going to add F plus G, I would have my x squared plus my 4x minus 7. So do y'all want to take a guess at my domain? Or do y'all want me to do this one and then I'll let y'all do some more? So let me ask y'all this. Monday, when I was doing all the domain stuff, there was only one thing we were worried about on our domains. So y'all want me to get an example. Okay, so let me show y'all this. The only thing I'm worried about on my domain in this chapter are fractions. So do y'all see any fractions here? I got an x squared term. I got a 4x minus 7. So since we do not see any fractions, this domain will be all real numbers. So we'll have x such that x is a real number. All right, so I'm gonna let y'all do the subtraction. F minus g of x will be my f, which is x squared, minus my g, which is 4x minus 7. So what is my domain? So let me ask y'all this. Oh, Claire, you got it, because there's no fractions in this either, right? So since we have no fractions, good job, y'all. It's going to be the same as the first, which is all real numbers. Remember, our domains, we don't have to kick out any numbers if it's not being divided looking like a fraction. All right, product would be f times g of x. That's going to equal my f, which is x squared, times my g, which is 4x minus 7. Any guesses on that domain? Same thing, all real numbers again, y'all, no fractions. So x such that x is a real number. Now, I will say this one. This one didn't ask for the quotient, which is division. But if I was taking f of x and dividing by 4x minus 7, then I would have to find numbers that might make that 0 in that denominator. I think what they're really wanting y'all to realize is that adding, subtracting, and multiplying pretty much always have the same domains, okay? All right, y'all, so let's see what we do next with some domains. I'm gonna move this paper over because it's folding up. All right, this time, watch this. f of x is going to equal 1 divided by x minus 3. G of x is going to equal 9x to the third. So once again, I'm going to find the domain of the sum, difference, and product of f and g. So we'll start out with our sum, which is adding. So f plus g of x is going to equal my f, which is 1 over x minus 3, plus my g, which is 9x to the third. So yes or no, will this domain be all real numbers? Oh, Karen, good job. There's no way it can be because we do have a fraction. Okay, so we have a fraction. So since we have a fraction, we're going to take that bottom, we're going to set x minus 3 equal to 0. So anytime you got a fraction, set that denominator equal to 0 and solve it. Whatever solution I get, I'm going to kick out of that domain. So y'all solving this, we're what? Basically going to add 3 to both sides. So that we get x equals 3. So since x equals 3, I'm kicking that out of my domain. So our domain would be x such that x is a real number and x cannot equal 3. So y'all with me on that? And really, fractions are all we're going to be worried about, okay? So y'all try this one. F minus g of x will equal your f equation 1 over x minus 3 minus the g, which is 9x to the third. So do y'all want to guess that domain? It's a real number and x cannot equal. That's it, right? X is a real number and x cannot equal 3, so it's exactly the same. Yeah, it's only fraction. So in Taylor, every one of my operations as I go through here, even when I do what, my f times g of x, that's just going to be 1 over x minus 3 times 9x to the third. So Taylor, would this one be the same? Yes, there you go. Yeah, because I only got the one fraction. So once again, it's going to be the x such that x is real number and x cannot equal R3. Okay, so y'all make sure when you're doing these, adding, subtracting, and multiplication always have the same domains. Division would be a little different. And I got one where we're about to do a little division. Let's see. You want me to turn over and try one with division? So this one, they're giving me f of x equals 4x minus 5. G of x is 5x minus 35. We're going to determine the domain of f divided by g. So y'all, let's see. F divided by g would be my 4x minus 5 divided by my 5x minus 35. So will this domain be all real numbers? Good job. So no. So what numbers would y'all kick out of this domain? So let's see. We know we got a fraction. Oh, perfect. You got 7. That's what I'm about to get, right? So since we got a fraction, we're going to set 5x minus 35 equal to 0. So that negative 35, you're going to add 35 to both sides. And then let's see, divide by 5. So that x equals 7. So Tanner is asking if I could simplify the negative 5 and negative 35. The only way you can simplify these kind of fractions doing that is if all 4 terms will divide by the same number. So what's keeping me from dividing these by 5s is that 4, okay? You have to be able to do it through the whole fraction when you do that kind of stuff. But that'd be more work than you needed because all you had to concentrate was on the bottom. And you want to find any numbers on the bottom that make it equal 0 so we can kick them out of the domain. So since 7 times 5 is 35 and 35 minus 35 made that a 0, to kick that out, our domain would be x such that x is a real number and x cannot equal 7. All righty, so questions on that. And so y'all just remember, anytime we're talking about domains, all we are really worried about are whether we have fractions or not, okay? If it's not a fraction, we put all real numbers. If it is a fraction, it'll be all real numbers, and then we'll tell what number it can't be. All righty, so let's see. Well, that pretty much covers 2.4. And we got a long weekend. I won't see y'all again, remember, till next Wednesday. Friday is a holiday. I mean, Monday's a holiday. So we won't have a webinar that day at all. So when we come back Wednesday, we're going to knock out 9-1 and 9-2. They're not too long. I like to keep it sort of mellow the first couple of weeks. because y'all are getting new in school. Make sure y'all get the internet up. Make sure we don't have any more students being added and dropped. So, any questions? All righty. Is anyone going to need support lab to help today? All right, so I'm seeing a lot of no's. So I'm gonna stop my share. I'm gonna send our video out. Let me get it